the need, and what we show is you can typically live on a small fraction of the total qubits you think you need. So that's sort of like Archimedes' lever, where you use the leverage from the fact that you can take a problem you thought you needed 1,000 qubits and show that you can live on, say, 200. This is a made-up number. And therefore, 200 you can get now. Therefore, you can deploy your commercial application 2 years before you thought you could. So you're accelerating time to deploy. And for a company, time to revenue. Now, I want to close in 5 minutes with the idea of machine learning and where the opportunity. Let's call it synthetic chemistry and generative AI. Okay? It's a very broad area. I'll allude to some in some detail, some of them, not all, because you get the idea. So these are topics within synthetic chemistry where the quantum computer is programmed to simulate a chemical reaction for generative AI model, right? So the opportunity space that we see in a particular form of this generation, and that is synthetic image generation, creating images, which you have seen recently in some successful demos, I'm sure, where it's completely artificially generated with some seed image you get from somewhere. So this sort of synthetic generation is, you can see on the axis, basically a low FID score means that you're doing well. So as the y-axis became high, the Q dense, the red dotted thing, you can see it drops quite well. That's a quantum simulation of the image generator using generative AI. So there are data points like this that are coming about, and what we ourselves do using our philosophy is to be able to take a model like that, but show that you can deploy it using our techniques on a smaller quantum machine sooner. So we are not in the business of creating AI models, nor are we in the business of optimizing them in traditional AI. But we are in the business, at least as of a few months ago, in trying to get into taking a model which lives in the quantum world, or we can make it live in the quantum world, but by itself would have required a machine in 2028 or 2027. But you can live on it instead in 2025 or 2026. And you get the advantage that you don't have those very large power and resource requirements, and also eco-friendly situations, right? So that's the general philosophy of our company. And so can we make any of this really happen? So last year we did a study with an optimization problem. An optimization problem is trying to find a minimum or a maximum of something. And those are all names of different IBM machines. They name them after rivers and cities. With very number of qubits. And there is something in a quantum machine because of the fluctuations of these qubits, which is called its fidelity. How accurate it is. Think about it as probability. So probability 1 means it's perfectly accurate, let's say. Or 100% fidelity is probability 1. So the challenge said try to hit 99% on this machine. And using this method and making the qubit demands less and deploying sooner, we consistently hit 100%. And that's on real quantum hardware. So this is not a simulation. You actually can upload it in the cloud, invoke a machine wherever it is, and run it on IBM hardware. The other side of the story is what are we pushing to do? We're trying to take something that needs, say, 1,000 qubits and say you can live on 200 qubits. 200 is now 1,026, 27, right? So IBM has put out some benchmarks. The greenish blue curve at the bottom is when they will skip on the y-axis something called a certain quantum volume, the size of the problem. And it grows according to their projections along that line. Once you do our transformations to live on pure qubits, you get the purple line. That means you can move that point where you could get a certain volume from, roughly 2025 to last year, which is when we did, right? So the entire philosophy of what we do is that living on other people's hardware, which is any of these, we're agnostic as to who makes the hardware. It's an abstraction that we work with, And last but not least, the domains of applicability that I mentioned to you are real, and we are concretely looking at aspects of machine learning. And that last application you saw, the image generation synthesis application, is at the front of all this. So this is happening now. The question says that can I translate the market size and technology opportunity into some sort of return on investment type estimate for a given enterprise. So first, a high level comment, everything we do is in the enterprise space. It's all what they call B2B. So we don't do B2C because it requires individual customers, right? Now, the numbers that start out in this, let us call it calculation, are speed up and let us say scale, the size of the problem. So I didn't say this here because it's all about AI, but there are non-AI domains which are where this is more obvious because the domains are mature and they already have revenue. So we are looking at a particular supply chain logistics domain which has a TAM, a total accessible market of about 12 billion. And we are now in the process of showing that a problem that they solve can be scaled in size by a factor of 100 and done 10 to 100 times over time faster. So that means they have actionable information which would normally take a few weeks to get to in a day on a much larger global problem. So you can imagine the domains, without going into all the details, airline industry, shipping, correct? All the heavy supply chain kind of industries. The same optimization problem also plays a role in the battery design. But I went into the more future, forward-looking areas because the total TAMs in optimization are set. The accessible market is now well-defined. These are emerging TAMs. So for this forum alone, I picked areas, for example, drug discovery is a potential application, but the TAM on one of those tables was huge. Till, I would say, September, right, ChatGPT, before pre-ChatGPT, the TAM in that entire space was much smaller. Now, that company alone has a TAM that is huge, right? So, I picked areas where the markets are being defined for this talk. But there are mature markets where we are in-house working with companies like yours who have a customer base, but their problems are much less exotic and much more well-defined mathematically. So the markets for some of those areas are projections. Like drug discovery is a projection, correct? Protein folding, eventually personalized medicine is a projection. So I picked those because those are the more intellectually interesting future forward-looking areas for today's talk. And that's where AI and scale matter. But there we don't solve the problem at the base level. We try to take your AI solution and deploy it sooner at a larger scale, less cost. Now it's obvious to you that if something is 50 times faster, it's going to be cheaper. And if you solve something 1,000 times larger, also better. The exact dollar value, and that's a bit of a question mark, the more further out you are in the market.
Thank you, Dr. Krishnapalam. In the interest of time, may I request the audience to take any further questions offline? Thank you so much. In fact, I was thinking maybe 7 years. We think 2 years we'll have to rename this to AI quantum based. We'll probably call it quantum machine learning.
We said in 2 years you might have to. We are a bit bullish in our company. We're accelerating. So I wouldn't be surprised if I was sitting with you this December to say let's do it next year. We're optimists. We're optimists.
Thank you so much. Thank you, sir. Thank you so much. We are now at the end of the conference, but before we end the conference, I would like to call on to the stage a very special person. I think this is already imprinted to all of our minds. May I invite Professor K.K. Babu from the National Institute of Fashion Technology, NIFT. If you are wondering what has lift to do with AI base and everything, Everywhere you're seeing the logo over here. Everywhere you're wearing the shirts, volunteers, everybody, everywhere the logo is there. It was designed by Dr. K.K. Babu. Sir, if you can just please come on to the dais once. The dais once, just one minute. Thank you so much, sir. This is a wonderful thing. In fact, we're thinking we'll use the same logo to the center for the center we have just spoken about as the Center for Research and Development of People-Centric AI. And I think nothing encapsulates this better is what I thought. He said, no, Praveen, I have a better design. You have yet to look at it. Thank you so much, sir. Thank you for doing this. And then I'll ask you to stay back. We're at the stage where we're doing vote of thanks. I'll first do the formal ones. First of all, thank you to the Department of CSC, University College of Engineering, JNTU, Supriti ma'am, if you're here, may I request you to come onto the stage. Rajni ma'am, Padmajarani ma'am, any of them, if you're here, please do come onto the dais. And JNTU, to the Vice Chancellor and to the University who have provided us with this thing, with this venue. It's wonderful. Thank you so much. To our supporters, Anurag University, Anurag, if you're here, please do come on to this. If you're here, Anurag University has been a huge support to this thing. Anurag University, Meta is a supporter of this conference. We have Hitam, Sridevi College, and a lot of JPNC has also been a supporter of this conference. In addition to that, the supporters and everything, you've seen the partners, you see the AIML partners as TechVedica and DigiQuanta. Thank you, DigiQuanta and TechVedica. CX and AI partner being OzoneTel, or visual media partner, OneBlink media partner, Hans India, and lots of others I might be missing because they're playing with full screen. I typically like to copy some of these things, but that's okay. Using some of this stuff. What made all of this possible is not just the supporters, not just these organizations I said. Naveen, we will show you on the stage anyway. You can just please play other behind the scenes as well. I wanted him to play the behind the scenes because there's a lot of work that has gone into it. We had 2,000 people. It was not just because Naveen was eating. Good. He doesn't want to say anything else. So what I'll do is I'll call everybody on stage. I'll first start with the person behind all of this stuff. Kiran is the founder of Swecha. Please come on to the dais. We'll start with Kiran, but with the whole team effort, might I call all the preparatory committee onto the dais. All the preparatory committee, Pratap sir, Nag, Srinivas Garu, Vamsi, please come on to the dais. And all our speakers who have made this possible. Maybe Rajagaru sir, come on, please come on to the dais. Suresh Garu, all the speakers, Anand, Sarajankar, please do come on to the dais. Krishna Palangur, might I request you to please join us on stage. Please here. Come. All the preparatory committee, the Swecha executive committee which has worked hard, Dr. Pavani, Divya, Manjusha, Sahiti, Super Bloom Studios, if you're still here, I don't know if I Super Bloom Studios, I can see, yes, please, to join us on the stage. Divya ma'am is coming over here. Naveen, if you can stop eating and come join us over here, we'll provide dinner for you separately. Where is Rajshekhar? Rajshekhar? Chaitanya, hello, please. We also have the birthday boy over there. One, happy birthday to Ranjit. Happy birthday, Ranjit. Ranjit has turned 45 today. No, 50? 50, yeah? Divya ma'am is saying, why are you revealing the real age right now? Sorry, Ranjit, should I say what? I shouldn't say your real age. Okay, Ranjit is not 45. Hey, hello, Chaitanya. Hello, please, somebody escort Chaitanya out to the... thank you. Ramesh, all, Shashikant. The question I know that I was everybody was asking me, how is, Shashi still alive? I don't think he has slept in the last 1 month. Where is Shashikant? Shashikant over there. Okay, Shashikant is over there. Singing, please do join us. Srinivasan Damani, yes. Dr. Srinivasan Damani. That's why he's not coming on to the dais. Next year only, 77 to 80, I don't know. Ready for it. We'll have the mics, I have the mic. If we hit 80, then we'll go to 90, then we'll see if we can actually hit 100. Doctors over here, Suresh got 100 decibels, is it safe for the ears for like 2 seconds? Yeah, I thought okay, no, yeah. Okay. Volunteers, also all the participants, may I request you all to come here closer. We'll see if we can hit 100 decibels over there. Shall we all come here? Shall we all come closer here? Come closer. Come closer. Let's see if we can hit. In the morning we tried to hit 100 decibels. Naveen ensured that we could not hit it because he was hiding the laptop somewhere there. He was hiding the laptop there. Now also we have to shout.